Section number 2, Basic Concepts of Earth-Sun Geometry. Lecture number 1, Revolution of Earth around the Sun. Learning objectives of lecture number 1. Learner should able to understand Earth's orbit around the Sun. Learner should able to understand revolution of Earth around the Sun. Learner should able to understand axial tilt of the Earth. Earth's orbit around the Sun. As we know, the Earth is revolving around the Sun in the elliptical orbits. The variation in the distance from the Sun causes the amount of solar radiation received by the Earth to annual vary by 6%. Basically, when the Earth is revolving around the Sun in the elliptical orbit, at an aphelion, the distance is higher, and the perihelion, the distance is lesser. Due to the variation of a distance, there is also the amount of solar energy variation is vary annually by amount of 6%. On the 3rd of January, that is the perihelion, the Earth is closest to the Earth. That is, the distance between the Sun and Earth is 147.3 million kilometers. Like see in this diagram, the Earth is at this closest position from the Sun with a distance of 147.3 million kilometers. This is the January 3rd. On the aphelion, that is a July 4th, the distance is very high compared to all other distances. It is 152.1 million kilometer. This is the aphelion position is coming from the Earth on the 4th of July. There is a position of Earth on the different solstices and equinoxes has been given. This is the first June solstice or the summer solstice from June 21 to 22 in the northern hemisphere. The position is nearer to the aphelion. Next is the March equinoxes from the March 20 to 21 in the northern hemisphere. The position is here. Simultaneously, the September equinoxes, September 22 to 23, it is occurring. The position and the distance between the Sun and Earth for the March and September equinoxes is almost same. Next is the December solstice occurring in the northern hemisphere from the December 21 to 22. This is nearer to the perihelion. Like the Earth position is situated while it is revolving around the Sun. Revolution of Earth around the Sun. Revolution of Earth around the Sun in the different positions over the elliptical orbits. Figure shows a side view of Earth in its orbit about the Sun on 4 important dates, out of which when a Sun is located here at the foci point and the Earth is rotating at an revolving around the Sun in the elliptical orbit, the farthest distance from the Sun at this position, basically when we see, this is the summer solstice or June solstice we can say. On the northern hemisphere, the Sun's radiation directly falling over the Tropic of Cancer. Due to when the Sun's radiation is falling directly over the Tropic of Cancer, and because of this, there is occurring a summer solstice. Earth is tilted about its axis at an angle of 23.45 degree. Therefore, when the sun's radiations and the light is falling over the Tropic of Cancer exactly 90 degree, that time the summer solstice is happening or the June solstice is happening. Simultaneously, there is a winter solstice occurring. It is also called as the December solstice. In the northern hemisphere, the sun's radiation is directly falling at an angle of 90 degree over the Tropic of Capricorn. Therefore, on the northern hemisphere, there is a winter, and southern hemisphere, there is a summer is happening. In the spring and autumn equinoxes, it is occurring simultaneously in the September and the March equinoxes. Basically, spring equinoxes is also called as the September equinox, and the autumn equinoxes is also called as the March equinoxes. In this case, the sun's radiation is directly falling exactly 90 degree over the equator. Therefore, on the both sides, on the northern hemisphere and the southern hemisphere, equal amount of radiation is occurring over the Earth. These are the major 3 or 4 positions occurring throughout the year when the Earth is revolving around the Sun. Axial tilt of the earth. The solar altitude is normally measured from the either southern or northern point along the horizon and begins at the 0 degree. Maximum solar altitude occurs when the sun is directly overhead and has a value of 90 degree. Maximum solar height at the equator goes from 66 degrees above the northern end of a horizon during the June solstice, like in the first figure it has been shown, and the second figure it has been directly applied on the northern hemisphere, that is the summer solstice or the June solstice. The sun's radiation exactly falling on the topic of Cancer. Basically, the direction of sun's radiation is exactly 90 degree falling over the tropic of Cancer, and towards the equator the angle subtended with the sun's radiation and the earth is 66.5 degree negative side basically. So to directly overhead on the September equinoxes and then down to 66.5 degrees above the southern end of the horizon during the December solstice. In the summer equinoxes it is 90 degree, and in the winter equinoxes it is 90 degree to the tropic of Capricorn. In the both side also, the equator the sun is falling at an angle of 66.5 degree positive and negative in the both side, when the earth is revolving around the sun towards the farthest distance and the lowermost distance.